section 7.5. Just looking at some other equations we're going to solve. Ones that involve tangent, secant, cotangent, and cosecant. I wanted you to know I posted this table, and for those of you who have been using your hands to find these, I think we're getting pretty good at it. This table will just help us a little bit more streamline our problems, and also it has the tangent and these other functions here that we can easily find the exact angle if we get one of these answers. So will you be using this? I suggest that you print a copy out for yourself, and you could use that. So we're going to get right to it. Today we're going to be looking at some equations involving these other functions, and we have our Pythagorean identities, and so I'm going to add two here that we're going to need today, and that is we know this one, sine squared theta plus cosine squared theta equals 1. That's just like y squared plus s squared equals 1. This one is one for tangent and secant, and this one for cotangent and cosecant. So the goal will be, again, if we have two different functions in the same problem, is to try to get rid of one of them. There's a couple of other identities we're going to need today, and that are the reciprocal identities. Mostly this last one. If we have both cotangent and tangent in a problem, we can use this identity. Okay, so let's, without further ado, get on to example 1. Example 1 is well, I'm not sure what to call it, but here it is. Tangent squared theta minus 2 secant theta equals 2. So I'm going to just start off with this one right here. Now, I want you to know that using previous techniques, we can solve this, but it doesn't always lead to a successful solution if we do the old method. But I'm just going to show you the old method just in case you want to see it. I'm going to go through this really quick here. I've got all the steps. So there's my original equation. I'm going to switch to x and y. So that's what we used to do. We're going to do it a different way today. But you can solve it this way. You have that denominator that you can clear by multiplying both sides by x squared. When you do that, you get this. Now this involves both x and y, but we have a y squared. We can substitute in 1 minus x squared using our Pythagorean identity. We can simplify this or rearrange it into standard form. That's just like adding x squared to both sides and adding 2x and subtracting 1. Then we could ninja star that to factor it, and we get these two answers. So that'll work for this problem. It won't always be successful on problems like this, though. So this is a more streamlined way to do it. That's going to require a little bit more knowledge base. Here it goes. This is our given problem. The first thing we're going to do is we're going to notice that there's both tangent and secant there. So we're going to use the identity. And I look at my identity for tangent and secant, and I want to get rid of the tangent because it's squared. So if I rearrange in that formula up there, I get tangent square theta equals secant squared theta minus 1. So I'm going to use that to substitute in here. So secant squared theta minus 1 minus 2 secant theta equals 2. Okay, now I just have to simplify this. I have a minus 1 here and a 2 there. This is not really in standard form. So you can leave secant and secant, you can leave your secants in there, but it might be easier just to use a variable. And since x and y are usually cosine and sine, I'm just going to use a z. Just make this a little bit easier to solve. So z equals the secant of theta, so that I could just change to a different variable and make it easier. So that's z squared minus 1 minus 2z equals 2. And then I can see how that would go into standard form. I dropped the parentheses there, that's okay. I want to subtract 2 from both sides. So I get z squared. Rearranging, I could put my z term next. 2z, and then negative 1 plus negative 2 is negative 3 equals 0. And this is called standard form. Next, I'm going to factor it. So let's just set up a ninja star here. On top goes negative 3. On the bottom goes negative 2. We have our z's on the wings. And looks like 3 times 1 is going to work as long as the 3 is negative. So I get z minus 3 times z plus 1 equals 0. Using the zero product property, I get the two answers. Z equals 3 and z equals negative 1. So basically adding 3 to both sides and adding 1 to both sides. So there it is. And now I know that's my secant theta. Okay. So I have secant theta equals 3 and secant theta equals negative 1. All right, now I'm going to look on my table and see if I could find that. So on the table, I have the secant, and I want it to be 3 or negative 1. I don't see any 3's, but I do see a negative 1 here, and that's it. So let's go ahead and see. That would be at pi. So I'm going to go there. So that means that theta equals pi. And this one I don't know. So I'm just going to draw my unit circle to see where this is. So this is my, pi. And then where does secant theta equal 3? I don't know. Now here's where we have to switch this to 1 over the cosine of theta equals 3. So I could either use a calculator or some other method. That means that cosine of theta equals 1/3. And so that's my x coordinate. It's 1/3. So it's going to give me these two solutions, and I have to find those. So in order to find those, and it's not a common angle, we use our calculator. Make sure we're in radians. So mine's not in radians. And then I'm just going to do the inverse cosine of 1/3. I get 1.23, so theta is approximately 1.23. That should be this one, 1.23 radians. And the other one is going to be negative 1.23 radians. So to get that, I'm going to go 2 pi minus this answer to find that as this would be negative 1.23 radians. So I have 2 pi minus my answer, get 5.05, approximately 5.05 radians. So that's my other answer here. So let's see if I could get that. Theta equals 1.23. Theta is approximately 5.05. Now if I want all the general solutions, all these are unique, so it's just going to be theta equals pi plus 2k pi. Adding a circle gets me back to the same. Theta equals 1.23 plus 2k pi, and theta equals 5.05 plus 2k pi.